All right, well, happy Monday. It's week 7. Time is just ticking right along. What's that? Don't remind you? Yeah, I know. Sometimes I feel like, sometimes I'm like, didn't 2022 just start? I remember I was like, oh, these are my New Year's resolutions. I'm going to do this. And I'm like, oh, I just gave up on them a little while ago, but that was like, oh no, that was actually February, so I don't know what happened. But I could start back up if I wanted to. All right, so we are talking about some of the object-oriented features in Python, and we saw classes and things like that. A common an important concept in any kind of object-oriented system is this idea of inheritance, because a lot of times you want to have similar classes without having to redefine an entire new class. Okay, so inheritance basically allows you to create a new class that is just kind of like a modified version of an existing class, right? So you have a class defined, and you say, you know what, we need something to kind of apply in these situations, but I don't want to have to like redefine the entire thing. I just kind of want to create like a copy of it, but just make some small modifications to it. Okay, and so I'm following the example in our textbook, the textbook Think Python, and so if you haven't been doing so, please do keep up with the reading. I also have to give you another homework assignment, so there's going to be I'll release a couple of homework assignments. One will cover pandas, and then the other will cover object-oriented stuff. But I'll release them kind of, I guess, simultaneously. Would the pandas one do first, and then the object-oriented stuff do later? But no, it's going to be like you do it on your, like the homeworks that I've been assigning, and you do and you submit. Okay, so the example that we're following is, kind of based on poker, and so poker is this card game where your standard deck of cards has 52 cards. There's 4 suits, and each suit has different what we call ranks. Okay, so first we're going to start by defining a card object. Okay, and the card object really only needs to keep 2 values. Okay, a rank and a suit. Okay, so the ranks go ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. And then as far as the suits go, we have spades, hearts, diamonds, and clubs. And a lot of times people don't rank suits, but if you play the card game Bridge, there is a ranking of the suits where spades is the strongest suit and clubs is the weakest. Hearts and diamonds fall in between. I get, depending on what other card games you have, you might have different rankings of suits, but this is kind of, I don't know, accepted, and so we'll kind of store this in. And how should we store these? One is if you store them as strings, it will be difficult to kind of compare cards, because the way you compare them is with alphabetical order, and then jack, queen, and king, internally we can think of them as 11, 12, and 13, but if we store them as strings as jack, queen, and king, then it becomes difficult to rank. So what we'll do is we'll internally store these attributes as numbers. Okay, so we will encode the suits as integers, and we'll also encode the ranks as integers. And so we'll encode the jack as 11, and queen as 12, and king as 13, and spades hearts, diamonds, clubs, we'll go 3, 2, 1, 0. So we'll start off by defining a class, and we'll call this class card. And we learned the double under init, the initialize method, which basically takes kind of your input values as far as when you define your thing, and then we'll store them, okay, into some attributes. So, within our init method, we create two attributes, self.suit, self.rank, okay? And we also define default suit and rank, which will be the 2 of clubs. And that's what we have, okay? And so here we can create a card. Card suit 1, rank 12 will be queen of diamonds. And, we can do this, and we can do queen. What is queen of diamonds? And it just says, oh, you know what, this is just a card object. And so we can ask, what is queen of diamonds dot rank, okay? And it comes back and it reports 12. But, again, accessing the attributes directly is probably not the way we want to go. So what we'll do is we will create a double under string method, and this will give us the string representation of the card. And so what we'll do is we will look up so we have suit names and rank names, okay? And so here these are these lists of names, and we can kind of use self.rank to basically subset or locate one of the values in here, right? So I can do card.rank names, and we'll get the self.rank, and then card.suit names, and we'll get the self.suit, and then we'll format into the string with curly brace blank of blank, right? And so this will be the string method that we have here, okay? So so these would be so suit names and rank names are technically class attributes because they're associated with the card and not with the self. So notice that we're doing card.rank names and card.suit names, okay? Because they're associated inside the class and not part of the self here. And that's separate from the instance attribute, which such as the self.rank and the self.suit, which are particular to this particular instance, okay? So anyway, when I call print on a card now, it's going to invoke the string method, the double under string method, to kind of create this, okay? So here we will define a card, suit 2, rank 11. And so when I invoke this, it will get jack of hearts, right? So now that I'm calling print, it's going to look up under suit rank 2. Okay, suit, the suit name's index 2 is hearts, and then the 11 is the jack. Okay, 1, 1 will be ace of diamonds, 3, 6 will be the 6 of spades. Yeah, question?
I might have missed when you said this, but why do you have the rank defaulted to 2? Like in the class?
You just had to pick something. Okay, I could have picked any other number. So rank 2, rank 2 would often be considered the weakest card, because the ace, even though it's rank 1, often it's treated as like the strongest card. So this is just kind of defaulting to a weak card, but whatever. Okay. All right. So now we might want to add additional methods. All right. So last time when we defined other double under methods like add, and when we did add, we were able to invoke methods or functions like sum, and sum would sum would work here, okay? So here we're going to use a special double under method called less than and double under EQ for equality, okay? So we have double under LT, double under EQ. And this will tell us, how do we rank these? Is one less than or greater than another, okay? So here I'm gonna define two methods, LT and EQ. And we have choices here. Which one's more important? Is the suit or the rank more important? And just arbitrarily, we're going to pick suits as more important, okay? So, depending on the game, the rules are different, right? Where all the aces are more important than this, but, here we're going to say suits are more important. So that means, the two of spades will be more important than the king of diamonds or something like that. Okay, so to do this, we are going to do, and I guess our inspiration would be like new deck order. Like if you open a fresh deck of cards, a lot of times they're put in arranged in order by suit or something like that. Okay, so to compare our lesson, what are we doing? T1 is self.suit, self.rank. So what are we doing here? We're creating a tuple, okay? A tuple with the suit first, then the rank. And then we're comparing it versus the other. And so tuple 2 is other.suit, other.rank. And then we compare T1 less than T2. So when you compare tuples, it compares the first elements first. And then if those are tied, then it looks at the second element, okay? But if the first elements are different, then it's going to just return which one is less than the other. So here we're going to do self.suit versus other.suit. We compare that first, and then we do that, okay? And then here we have a test for equality. And basically we just create two tuples again, and then and we're going to just return true or false if they are equal. All right, is that okay as far as the less than and the equality methods? And these are double under methods, dunder methods, meaning they get special treatment by Python, and they kind of work in conjunction with the operators that we're accustomed to, the less than, the equal operators, and then they'll also get invoked with other kind of things as well. All right, so I'm going to go ahead and I'm going to create a new card. This will be the Queen of Diamonds, and here we'll have the Jack of Hearts. Okay, so is the Queen of Diamonds less than the Jack of Hearts? So we arbitrarily said suits are more important, and as far as the suit order, again, arbitrarily, diamonds are ranked lower than hearts. So in our case, the Queen of Diamonds is ranked lower than the Jack of Hearts. Okay. Here, I'm going to create a third card, which is also the Queen of Hearts. So we're going to ask, is Queen of Hearts less than Queen of Hearts? That's false. But I could ask, is card 3 equal to card 2? Oh, you know what this is? Hold on. Queen of Hearts. Oh, no. I need to do card 1. Okay, card 1 is Queen. Oh, they are different. Okay, card 1 is Queen of Diamonds. Sorry, I'm confusing myself here. They're not going to be equal. Okay, so is card 3 is Queen of Hearts. Is Queen of Hearts less than the Jack of Hearts? That's going to be false. Card 4 is the Queen of Diamonds. Okay, here we go. Sorry, I got my examples mixed up. Card 1 is Queen of Diamonds. Card 1 is Queen of Diamonds, and card 4 is also the Queen of Diamonds. Are these equal? That's true. Card 3 is the Queen of Hearts. Is card 1 equal? Queen of Hearts equal to Queen of Diamonds? That is false. Okay, yeah, question.
So I'm sort of confused on how it like automatically calls the like comparison function in class.
How it does that? So the LT in by defining double under LT, this will invoke comparison operators. Okay, so this says, I mean, so we could have defined some function called less than, okay, like this. Yeah, and then we could do card3 dot less than like this, and we could do that.
You spelled it less than. Okay.
Oh, okay. Yeah, I spelled it all wrong. Okay, so we could do this. Okay, but then here it wouldn't know what to do with the less than operator, but I could kind of define this, and then I could invoke it this way. But by using kind of these special double under methods when I define a class, now Python says, oh, you know what? When I see stuff like this, okay, now I know to invoke that method when I use kind of the less than operator.
So does that only work with the less than operator? You need to make another one for the greater than operator?
Actually, it will work for the greater than operator. Oh wait, yeah. So when you create the LT, then Python goes, okay, less than means we're going to do self then other, and then if I use the greater than operator, then it's going to then it will do other. It will kind of swap the positions of these things, right?
Okay.
So it's Python does like some pretty cool stuff like that, right? They're just like there's cool stuff when you use the double under methods. Okay, so if you have an application where it makes sense to use the dunder methods, you should. Okay, so and I'm trying to point out some of the most important ones, like the double under add, and then the double under less than and equal to comparison operators, and that will do that. And it did. I think yeah. All right. So like if I create a list, card 1, card 2, card 3. Okay, so that's what we get here. Okay, so if this is what we have here, I can also, do sorted on this, and it will sort the cards. I guess this is already sorted. And this, again, sorted this. Okay, so you can, because you have this less than operator, you can invoke sorted and things like that, and it will sort them because it understands how to put them in order. Okay, so here I have, card 2, card 1, and stuff like that. It will sort them, even though card 2, card 1, card 3 goes hearts, diamonds, hearts. If you call sorted on it, it'll go diamonds, hearts, hearts, and put them in the correct order, which is, in my opinion, pretty cool. Okay, so with that in mind, let's create another class that will kind of build off of this. Yeah, question?
Before I move on, can you help me get some intuition for how the less than operator works with tuples?
Yeah, so it kind of works like alphabetical order. Like,
Yeah, I guess I just didn't really understand how I understand that it came to the right conclusions.
Yeah.
But if I try out on my own, like true, false, less than false, true, or something like that, each of those, I assume it probably distributes element-wise and then somehow does something. I'm not really sure how it comes to its conclusions.
Wait, okay, it's true. I don't know. How do we,
It doesn't make any sense to me.
what is true less than false?
I assume it casts them to 0 and 1, so like I imagine this evaluates to false.
Okay, yeah, that is false.
When you have multiple of them on times 10, I don't know what that means.
Okay, so we'll create tuple 1 will be true, comma, false, true, false, true. And we'll have tuple 2 be false, true, false. And tuple 3 will be false, false, false. Okay, so if I understand tuples correctly, this one is equal to 0, 0, 0.
Mm-hmm.
And you kind of think of it, and this would get cast as 0, 1, 0. And this one would get cast as 1, 1, 0, 0. Okay? Or 1, 0, 1.
Oh, so if you call sorted on this, it'll like in almost like alphabetical order.
Yeah, it'll do it like alphabetical order. Yeah.
Okay.
So T3 should be less than T2, and T2 will be less than T1, and T1 is greater than everything else. So if I do T1 is less than T2, that'll be false, and so on and so forth. So it's like alphabetical order, and you can kind of think of this as how would you alphabetize these words? And we would put, if you had to alphabetize these, you do AAA first, then ABA, and then BAB, right? So you look at the first letter, compare all of those, and if there's a tie there, then you go to the second letter. And then if there's a tie there, then you go to the third letter.
Right, so it's almost like iterating through each element of the tuple.
Yeah.
If you ever find a point where, like, let's say you have tuple on the left and tuple on the right.
Mm-hmm.
And you're saying tuple 1 less than tuple 2.
Yeah.
If at any one of the elements tuple 1 is less than tuple 2, i.e. if they're tied up until some certain point,
yeah.
and at that certain point tuple 1 is less than, then it automatically returns true.
Yeah, yeah,
okay.
yeah.
That makes sense. So that also makes sense with the suits and the rings then.
Yeah, so again, it's kind of like if I had tuple 4 is the same, how would you sort these? This is not, this would be false, right? Because does tuple 4 come before tuple 3 in the alphabet? No, it doesn't, right? So they're the same. But you can ask, are these equal? And that they would do a comparison, and those are true. So yeah, it's just
there's a lot hidden in that less than.
Yeah. When you do tuple comparisons, it basically, you just when you have a tuple, think of it as like doing like alphabetical order, and so like if you have AAAZZZZZ, that's still going to come before this in the alphabet, right? Because you're doing the first letter versus the first letter, and then the second letter versus the second letter. And because the second letter is a B, okay, this is going to come after, right? If we convert these to like numbers and we said, A's are worth 1 and Z's are worth 26, and we added these up, sure, this will add up to more, but it doesn't matter, because when we do them alphabetical order, it's first letter versus first letter, second letter versus second letter, and in this case, the second letter here is an A, and the second letter here is a B. So this comes before the other.
Yeah, T1 and T4 are also just like numbers in binary, right?
Yeah.
So they're just like sorting the numbers in binary.
Yes. Yeah. Also. Yeah. Okay. All right. You know what? Let me give you your view quiz answer. First answer today is a C. C as in cat. think it's published. Okay. All right, so let's define a deck. So as far as the deck goes, we're going to create a list of a bunch of cards. Okay, so initialize, and here when we just say make a deck, we don't have anything in it. Okay, we're just going to say initialize, and we just create an empty list called self.cards. Okay, and within self.cards, we're going to basically create all 52 cards. We're going to go for each suit in range 0, 1, 2, 3, all right? And then for each rank in 1 through 13, right? So we just have 2 ranges, and then we're going to just create card, suit, comma, rank. So this will first do it for suit 0, rank 1, suit 0, rank 2, suit 0, rank 3, and then when we create that card, we just append it to self.card. So we're going to create all 52 cards here. And then we are going to, when we say print out the deck, okay, we're going to kind of just iterate through all the cards in the deck, and we're going to create a list. Right now our list is an empty list, and we just iterate and we just append the string representation of every card. And we're going to create a list with the string representation of every card. And then at the end, we're going to just return all the strings joined together using a new line character. So the dot join will take a list, and it will, if it's a list of strings, it just joins every element in that list using this. So you could use a space, and then it will be all the cards joined together with a space. But here I'm going to use a new line so that it's going to do that. So if I do, let's create a new deck, and then I print out the deck, it's going to join 52 cards, all the character representations or string representations of the cards, all joined together with a new line. So this is the list of all 52 cards here. Okay, so that is the deck, and we can define some methods to go along with it. Okay, so one is we can deal off a card, and so all the cards are stored on a list, so we can pop a card, right? Pop a card from that list, and we can have it return, right? So we can do pop a card, which is basically deal the last card off of the deck. So we'll deal off King of Spades. Okay. If we wanted to add a card, we can take the current existing list of cards, self.cards, and append whatever new card we have. And then if we wanted to do a shuffle, we can take self.cards and we can shuffle it. Okay, and random.shuffle will shuffle that list. Okay, and then sort will also, we can just call the sort method on the list, right? And so these things modify the lists themselves that exist inside the class. So, in order to get the shuffle thing to work, though, we have to import the random module. And so we've added a few methods here. All right, so here is the deck. Length of deck.cards is 52. All right, so we're just asking what's the length of this attribute. I can print off the deck, and we have all 52 cards there. I can shuffle the deck. Okay, and I can just ask, okay, here I don't want to print off the entire deck again, but we can just kind of check out like the first few cards and the last few cards of the deck, okay, and that's what we have. I can deal off the bottom card, 9 of clubs here. Okay, we can deal off another card, and we deal off the 5 of spades. And so if I say how many cards are left in the deck, we have 50 of them, And then if I were to just do print string.deck again, okay, we can see, yeah, now the last card in the deck is the 4 of clubs, okay? So we have that, okay? So that seems to be working. All right, so we have the deck defined, and now what we're going to do is we're going to create a new class that we want to use to kind of represent a person's like hand. So, you know, in a card game, you deal some of the cards out of the deck to different people, and so now people might have a hand with, say, like 5 cards in them, okay? And basically a hand, we want often the same kind of methods that exist from a deck, right? Like the ability to kind of just, you know, the string representation, right? That's handy. We want to be able to say like, okay, what are the cards that you have inside your hand, and how do we do that? Okay, so so here, if we wanted to create a class that inherits from another, when you define the new class, so when we define the class deck, we just said class deck, okay? But here we're going to define a class hand, and to show that it inherits from deck, we put after the name of the new class, we put in parentheses the class that it's inheriting from. Okay, so here I'm going to have class hand, and right now my definition for class hand is empty. I'm just putting a doc string so it doesn't error out, and we're just going to say this hand is going to represent a hand of playing cards, right? So here, yeah, it says a hand is similar to a deck in that they're both a collection of cards. They both require operations like adding and removing cards, but they're also different from a deck. So, for example, in poker, we might want to be able to compare 2 hands, or we might want to be able to compute some kind of score based on the hand. So we want to have things that are a little bit different, okay? So we're going to say relationships between classes. This idea of being similar but different leads to this concept of inheritance. And to kind of define a new class that inherits, you just put the name of that thing in there, okay? And so all the methods that we've defined for a deck, like pop card and add card and all of that, will exist, okay? And in this case, the deck is the parent class, the hand is the child class, and hand inherits from deck. And if we have nothing else defined, then hand will initialize from deck, and that's not what we want. So here, when we define a new hand, we just want to create self.cards to be empty. So here we're going to just have an empty hand, okay? And then here we just we'll give it a label as well. So here we're just defining a new attribute called label, and right now our label is, the default label is blank. So here I'm going to just create a new hand, okay? Where the label is new hand, and right now we have no cards in hand. It's just an empty list. The label is new hand. And so what I can do is we can deal cards from the deck into the hand. So we're going to create a new deck. I'm going to pop a card from the deck, and then we're going to add that card that I just popped into the hand. So now when I print the hand, we get the king of spades. So when I defined a new deck, it's in sorted order. So the king of spades is at the end, and so that gets moved over. All right. So to kind of make this a little bit more efficient, we're going to add a method to our deck definition, and here it's going to be move cards, and we're going to take cards from the deck, okay, and move it to a hand. So we're going to say move cards from self to some hand. So we have to pass this method a hand object, and and we're going to give it the number of cards that we want to move. So we're going to just say for I and range number, then we just repeat this many times. We're going to just call from the hand, we're going to call add card, and we're going to do self.pop card, right? So we're just kind of chaining and embedding methods into each other. So in the hand we have the add card method, and from the deck we're going to pop the card, and so we're going to do that. Okay, so we're just adding that method from move cards over here, and so we can do this. We'll create a new deck, we'll create a new hand, and we're going to move cards, 5 cards from the deck into the hand. And so now we have just kind of the 5 cards. It's just like you open a brand new set of cards. They're all sorted, and you're just going to take the top 5 cards and put them into your hand. And so you get Queen, King, Queen, Jack, 10, 9. So now you have almost a royal flush in your hand because you just dealt off the top 5 cards, right? So probably that's not how you do it. So we'll redefine a new deck. This time we will shuffle the deck, okay? And just so you can see what were the last 5 cards: 9 of spades, 2 of clubs, 6 of diamonds, 10 of diamonds, ace of spades. And what we'll do is we'll move 5 cards from the deck into the hand, and we can see, oh yeah, okay, those 5 cards got dealt off one at a time, and then we can just kind of ask, okay, well, what do we have? So the 5th card that we dealt off was the ace of spades, and then so at the top we have 2 of spades and queen of spades. Here it just said give me the last 30 characters, so that's why it just ends off, cuts off in the middle of a card name or something, but that's what we have there. Okay. So anyway, so that's working as we want. Let me give you your next view quiz answer, which is the letter D. D as in dog is your second answer. D. Oh, I guess this is it. Okay. All right, and so you can draw class diagrams, and there's some jokes among kind of computer programming that in your brain your class hierarchy is this beautiful structure in terms of where things are inheriting from, but then inevitably as you kind of build up your stuff, things get real messy and stuff, and it's unfortunate, but a lot of times that's kind of what happens. But you can also our textbook kind of talks about this, but you can draw class diagrams to kind of represent the relationship that exist between classes. So sometimes one class might contain another class, right? So early on we defined a rectangle, and the rectangle contained a point class object, right? And so this would be a has a relationship. So a deck has cards inside of it. So the definition of the class deck contains or has objects of class card, okay? And then one class might inherit from another, and so this relationship would be is, okay? So a hand is a kind of a deck, or a square is a kind of a rectangle, right? And so these inherit from each other. Squares are, is a kind of a rectangle. It's just, you have additional kind of, constraints to the square versus the rectangle, which would inherit from parallelogram, which would inherit from quadrilateral, which inherits from polygon. I don't know, right? So we can kind of think of how these things inherit from one another, and what is contained inside of a deck. A deck contains cards. Hands would be like a miniature version of a deck, things like that. Okay. And then oftentimes classes depend on another class in that, one class takes objects in the second class as, and that objects in one class takes objects in the second class as parameters or use objects in the second class as part of a computation. And this kind of relationship is a dependency. So, decks depend upon cards, and depending on what kind of methods you have defined, you have that. So you can ask, what are all of the variables inside a certain class? And it's kind of hard to kind of see. So inside the hand, right, we have two variables. One is, these are the attributes, right? Hand.cards and hand.label. So label is easy for us to read, that's new hand. But then the cards themselves are these card objects, okay, which currently we have a hard time reading because it's just a list. So I can do hand.cards, and we get this, and I don't think I can do this, right? So this is not going to work. But what I have to do is I kind of have to iterate through this. No. So you can kind of you can do like a little list comprehension here, where you can do like for I and hand cards, and you can ask for the string representation of it. But anyway, unfortunately, when you have cards inside of these things, you'll have this. And again, if you create like a shallow copy, you'll copy references to these objects, and so therefore, if you like swap out, if somehow you were to modify this card in memory, then that instance of the card would change everywhere, versus if you create a deep copy, it would create actual copies of the cards, card objects in memory. Okay, and so it says, here's a design suggestion. When you override a method, the interface of the new method should be the same as the old, meaning if you're going to create like a hand object based off of a deck class, the way you interact with the hand should be similar to the way you interact with the deck. You don't want to, so when it talks about interface here, it just says like, how do you interact with these things? And when the methods you call say, pop a card or something like that, you should keep those the same, okay? So it should take the same parameters, return the same type, obey the same kind of preconditions and postconditions. And if you follow this rule, you'll find that any function designed to work with an instance of a parent class like deck will also work with instances of child classes like a hand, or later on if you might have to define a poker hand. Okay, we'll wrap it up here. Let me go ahead and give you your last view quiz answer, which is the letter A as in apple. A as in apple is your final view quiz answer for the day. And we'll go ahead and end our lecture here. And let me clean that up. And I will post, I guess, your last kind of 2 homework assignments for the quarter. You can kind of get started on each of those, separately there. Okay, we'll end there, and we'll see you all on Wednesday.